Okay, good morning everyone. Sorry for the delay due to internet issues. Maybe if you could type for me that you are able to hear what I'm saying and able to see what is on the board or that I've beamed, then we can proceed. Okay, then we can start. Just waiting to reach 11 hours, then we can start. So we need to, I think we'll just do it for 1 hour 30. I'll just look at the successive differentiation. Then we'll look at on how to find derivative of inverse trigonometric functions. I think that's where we are going to end. I think for differentiation, we'll do it on Monday. I pray that on Monday we'll not have again internet issues in that space. So I'll again do the beaming. I would prefer to do the solving and the beaming than just reading through the notes, so that we can you're able to see what is going on with what I'm solving. Okay, Okay, I think we can start. Those who are coming, they will join us later because we don't have much time. Like I mentioned, it's not going to take a lot of time. So I'm switching to the normal video. So so do this now. Like I mentioned, to say we are going to look at some properties concerning successive differentiation. So and I mentioned to say, if you are given a function, we are looking at what we call successive. That is a successive differentiation. So we are looking at successive differentiation. So this part of the topic is very important because we'll be using it to determine whether the given point on a curve is a maximum turning point or it's a minimum turning point. So we usually use the second derivatives. Now, if you are given a function, from the normal sense, if you are given a function, say y, which is equal to f of x, then the derivative of this function with respect to x, the derivative of this function y, the first derivative. So the first derivative of this function, let me just say, then So if we have a function y is equal to, then the first derivative, that is the first derivative of y equal to f of x. So with respect to x is written as the same dy dx which we were finding. So, or we are writing as in function form, we are writing f prime of x. So what this is representing is the first derivative of a given function y, which is equal to f of x. So you either write dy dx, which is also equal to, which is just the same as f prime of x. So now the question is, if we differentiate, if this expression is differentiated again, which expression we're talking about is either this expression or this expression. So if we differentiate it again, so if the differential coefficient, remember we are having something like this, okay, or we can just put that out there. So now if this, so this formula we call it the differential coefficient. So if we differentiate it again, so if we take the derivative again, so what you're going to get now is the one you are seeing. The second we write like this. So the second derivative of the function y with respect to x. So you differentiate twice. Again, if you do it again, so if we differentiate, so now, or we write f double prime of x. If you differentiate again, so if again, after first thing you have the function y is equal to f of x, then you decided to differentiate it. What you're going to get is dy dx or f prime of x. Now, if you, after differentiating that function, which is the differential coefficient, you differentiate it again, what you're going to get is this. Now, if you differentiate again, you're going to get something like this: x power 3 or f triple prime of x. That means you are differentiating the given function 3 times. So you first differentiate them for the first time, you differentiate for the second time. Now, if you continue differentiating, if I differentiate this function again, this differential coefficient, what you're going to get is the d to the power 4 of y over dx power 4 or f. Now, instead of us putting triple prime 1, 2, 3, 4, what you usually do is you can either use the Roman numerals. The Roman numerals, you can just say 4, or you can put something like that, or the way they use the Arabic, or use the Roman numerals. That's why you remember last time I mentioned to say, so we put 4 there. Last time I mentioned to say there's a difference when you are dealing with functions, when you're doing a calculus, provided when you write it like this, f of x, this means you are multiplying the given function by itself twice. Now, there's a difference. This does not mean f2 of x. This means the second derivative. This means the second derivative of x. This means f of x times f of x. Okay. Now, so if we continue differentiating, then what you are going to get after you differentiate again, anytime. If we're going to take the differentiation procedure anytime, what you're going to get is d to the power n, then d of x, d to the power n of y over d of x to the power n. So you are differentiating this given function any times. So you can differentiate it 10 times, you can differentiate it 100 times, you can differentiate it 400 times, that's not a problem. Now, so let's look at some example that involves differentiation of a given function, either twice, 3 times, 4 times. Okay, now this is example number, according to our notes, this is example number 39. We are saying if the function f of x is equal to, if the function f of x is equal to 2x power 5 minus 4x cubed, then plus 3x minus 5, then we are saying find one. The first one is f double prime of x. The second one is f, the third derivative of the given function f of x. Okay, now let's look at the solution. So if we have such a scenario in our situation, now let's look at the function. So if we make it to be y, in short, if you want to do that, but which is also not just one and the same thing, the first thing that you need to do is you first need to find the first derivative of that function. You can't find the second derivative before finding the first derivative. So you should first start by finding the first derivative. Then from there now, that's when you can find the second derivative. After finding the second derivative, then you can find the fourth derivative. So now, looking at our function, so we are saying the first derivative of this function, or if we can say, so the first derivative of this function, f prime of x, this is equal to, isn't it? It will be 10. Okay, let me do this. This is the derivative with respect to x of the function 2x power 5 minus 4x cubed plus 3x minus 5. Now, if you look at this, this is going to give us 10x power 4 minus 12x squared plus 3, because here the derivative of negative 5 is 0. So what you have found is the second derivative of what? Of the given function f of x. Now, then the second derivative of the function f of x, this is just the same as the derivative with respect to x of what? Of the function f prime of the first derivative of f of x. So the second derivative of f of x is equal to the derivative, which is the derivative of the first derivative. So this is the derivative of the first derivative of f of x with respect to x. So then this is, so what you are supposed, now what is f prime? What is the first derivative of f of x? So the first here now, the first derivative of f of x is 10x power 4 minus 12x squared plus 3. That is the first derivative of f of x. Now when you apply the difference and sum rule, what you're going to get is 40x power 3 minus 24x. Then the derivative of 3 will be 0, so it will just end there. After you have found your second derivative, then in 2, they are asking us to find the third derivative of the given function f of x with respect to x. So then, now the third derivative with respect to x, this is number 2, the third derivative with respect to x of the function f of x, this is equal to the derivative with respect to x of the second derivative of f of x. And this is going to give us, now the second derivative of f of x is 40x cubed, 40x cubed minus 24x. So then this is going to give us, now this will be 40 times 3, which will give us 120x squared minus 24. So what you have done, you have found your second derivative of the given function f of x to be 40x to the power 3 minus 24x, and the third derivative of the given function f of x is 120x squared minus 24. So what you have done, you have successively differentiated the given function. Okay, then we have example number 40, which we call some mathematical problem that involves the derivatives of given functions. So I'll now look at example number 4. That is example number 40 which is in our notes. So this is example number 39, which we are just from doing, which involves successful differentiation. Now, some of the examples that I've put here, I think they are there in your tutorial sheets. So all you need to do is just to look at what we've done, because there are a lot of them in your tutorial sheet. So at least I picked one on each part so that we can resolve them together. And then as you'll be solving your own those questions in the tutorial sheet, to be like just a walkover, or rather like it will be easier for you. Now let's look at example number 40. So example number 40 in our notes. In our lecture notes, this example says if the function y is equal to the cosine of x plus the sine of x, then evaluate what are we evaluating? Evaluate x. Okay, in the range, evaluate the value of x in the range 0 is less than or equal to x, which is less than or equal to pi over 2, when the second derivative of the function y with respect to x is equal to 0. So in this case now, we want to find the value of theta, this angle x. So we want to find the value of this angle x such that when we take the second derivative of this, after substituting that value theta, where there's x, we substitute the theta, then we differentiate this given function twice. What you're going to get is a 0. So that is the value of x that you want to find. So now let's look at the solution. Let's look at the solution to this problem. Now the first thing that you're supposed to do is we are first supposed to find the second derivative of this given function y, which is equal to the cosine of x plus the sine of x. Now, first thing, we need first to find the first derivative. Now, the first derivative with respect to x of this function y, which is just equal to the first derivative with respect to x of cosine of x plus the sine of x. Now, this is going to give us the first derivative of cosine x is the negative sine of x plus the second derivative, the first derivative of sine x is the cosine of x. That is from the trigonometric differentiation principles. Next, after having found the first derivative of the function y, which is equal to cos x plus sine x, then now we can find the second derivative of the first derivative. Okay, so sorry, let me just restructure this one. So now then the second derivative of this function with respect to x, which you can also write as the derivative with respect to x of the first derivative of y with respect to x. So this is how you can write it. Now, the first derivative of y with respect to x, which will give us the derivative with respect to x. Now, the first derivative of y with respect to x is negative sine of x plus the cosine of x. Okay, so this is going to give us now the derivative of negative sine x. It's going to give us the negative of cosine x. Then the derivative of cosine of x is going to give us the negative of sine x. So this is what we are going to get. Now, after you have found the second derivative of this given function, now but the derivative with respect to x in our assumption, from the assumption that will be given, or from the question, but the derivative with respect, the second derivative with respect to the second derivative of the function y, the second derivative of the function y with respect to x is equal to what? 0. But the second derivative of the function y with respect to x is equal to 0. Then, hence, what we are saying is, this means that the negative of the cosine of theta minus the sine of theta, the negative of the cosine of x minus the sine of x must be equal to 0. So this will mean the negative of the cosine of x minus the sine of x must give us what? 0. From which we are going to get I think there is some typo from when we started. There is a typo. We're supposed to have a minus here, and those are just the typos I've observed. So we're supposed to have a minus, so that after having that minus, then we are going to have a minus here. Also a minus here. Then when we take the second derivative, sorry for that, we're supposed to have a plus here. Okay, yeah, that is fine now. Okay, so so what we have is that the second derivative of the function y with respect to x is the negative of cos x plus sine of x. But then, the second derivative from our question, from our assumption, the second derivative of the function y with respect to x is 0. During the solving, we have discovered that the second derivative of the function y with respect to x is equal to negative cosine of x plus sine of x. Now, if the second derivative of y with respect to x is equal to 0, and also the same second derivative of y with respect to x is equal to the negative cosine of x plus x, this means the negative cosine of x plus the sine of x will be equal to 0. After having that, that means, which implies that the sine